Hi, we're going to introduce the topic non-relational databases. But first, we need to know what is a database. By definition, a database is a collection of interrelated data used to support the activities of a particular organization. This is a repository of data that is defined once and then accessed by multiple users. Now, exist two main types of databases: the relational databases and non-relational databases. The major difference between them is how they handle data. If we have a database, the database provides us with many benefits, including self-describing. This means the database contains the data and the metadata which defines the data and the relationship between tables. Also, we have the views of data, and this means different users have different views of the data. Sharing of data. Uh, this is this is many users could access the same database and at the same time, and many more. So the relational databases like MySQL, PostgreSQL, and SQLite 3 represent and store data in tables and rows. They are based of a branch of algebraic set theory known as a relational algebra. Now here we have important aspects of a relational databases. This here is SQL, data integrity, transactions, and ACID compliance. SQL, or Structured Query Language, is the primary interface to communicate with relational database. SQLs became a standard of the National Standards Institute (ANSI) in 1918. SQL is used to add, update, or delete rows of data, retrieving subsets of data for transactions, processing, and analytic applications, and to manage all aspects of the database. Now we have data integrity. Data integrity is overall completeness, accuracy, and consistency of data. Relational database use a set of constraints to enforce data integrity in the database. Now we have transactions. A database transaction is one or more SQL statements that are executed as a sequence of operations that form a single logical unit of work. And finally, we have the ACID compliance. All database transactions must be ACID compliant. This means they have they they have to be atomic, consistent, insulated, and durable to ensure data integrity. We have the atomicity. The atomicity requires that every transaction as a whole be successful execute of or if a part of the transaction fails, then the entire transaction be invalid. The consistency mandates the data write to the database as part of the transactions must, must adhere to all defined rules and restrictions including constraints, cascades, and triggers. The insulation is critical to achieving currency control and make sure each transaction is independent into itself. And finally, we have the durability. The durability requires that all of the change made to the database be permanent once a transaction is successfully completed. Now, these are the most popular relational SQL data systems. We have Microsoft SQL Server, Oracle, MySQL or MariaDB, PostgreSQL, and Microsoft Azure SQL. Uh, a really little date data of Microsoft SQL Server is the Microsoft released its first version of SQL Server in 1988.
Hello, my name is Daniel Perez Zavala and I'll talk about non-relational database. Okay, a non-relational database is a database that does not use the tabular schema of rows and columns found in most traditional database systems. Instead, non-relational database use a storage model that is optimized for the specific requirements of the type of data being stored. For example, data may store a simple key value based as JSON document or as a graph consisting of edges and vertices. What all these data stores have in common is that they do not use a relational model. Also, they tend to be more specific in the type of data they support and how data can be queried. For example, time series data stores are optimized for queries over time-based sequence of data, where graph data stores are optimized for exploring weight relationships between entities. Neither format will generalize well to the task of managing transactional data. Some examples of non-relational NoSQL database are MongoDB, Oracle, Apache CouchDB, Redis, Firebase, Cassandra, etc. And some cases are MongoDB. It's a document-oriented and free schema database. That is, each entry can have a different data schema that has nothing to do with the rest of the stored records. It's quite fast when executing its operation since it's writing in C++ language. For the storage of information, it uses its own document system known as BASIN, which is an evolution of JSON, but with the peculiarity that it can store binary data. Next, Redis. This is a database created by Salvatore Sanfilippo and Pieter Nordius and is supported by VMware. This is a key-value type database. It can be imagined as a giant array in memory to store data. Data that can be strings, hashes, datasets, or lists. It has the advantage that its operations are atomic and persistent. Apache CouchDB. It's a system created by Apache and written in the Erlang language that works on most POSIX systems including GNU, Linux, and OS X, but not on Windows systems. The most important features include the use of RESTful HTTP API as an interface and JavaScript as the main interaction language. JSON files are used to store the data. Allows the creation of views, which are the mechanisms that allows the combination of documents to return values of several documents. That is, CouchDB allows the performance of typical SQL join operation. Next, Cassandra. This database is based on an open source key-value storage model that is written in Java. It allows large volumes of data in a distributed way. This base is used by Twitter, Apple, Facebook, Netflix, and SoundCloud, among others. Cassandra architecture is based on a series of equal nodes that communicate with a P2P protocol. It's developed by the Apache Software Foundation. Now, born of NoSQL. The acronym NoSQL was first used in 1998 by Carlos Strozzi while naming his lightweight open source relational database that did not use SQL. The name came up again in 2009 when Eric Evans and Johan Åkesson used it to describe non-relational database. Okay, the term NoSQL refers to data stores that do not use SQL for queries and instead use other programming language and construct to query the data. In practice, NoSQL means non-relational database, even though many of these databases do support SQL compatible queries. However, the underlying query execution strategy is usually very different from the way a traditional RDBMS would execute the same SQL query.
Continuing talking about NoSQL features and characteristics, the NoSQL system in the beginning was developed as a response to web data for the need for processing unstructured data from the millions of web users and the need for faster processing. The NoSQL model uses a distributed database system, meaning a system with multiple computers. For general research, NoSQL databases are the very choice for large, unstructured datasets compared with relational databases due to their speed and flexibility. The systems NoSQL, besides of being able to handle structured and unstructured data, they are also used to process unstructured big data. NoSQL now lead the way for popular internet companies such as Google, Amazon, and Facebook. These organizations process tremendous amounts of unstructured data from their users, coordinating it to find patterns and gain business insights. The key features of NoSQL databases that make it useful are a storing capacity of large volumes of unstructured data. That means that a NoSQL database can store unlimited sets of data with any types. A cloud-based storage. NoSQL databases like Cassandra make it happen to set up multiple data centers with much problems. So you can store and retrieve information for different servers and a fast development. The relational database is not an ideal solution when you are working in an agile environment which needs frequent feedbacks and fast iterations. Now, the characteristics of NoSQL. There are many characteristics that differentiate NoSQL from SQL. Some of the more important are no schema required. NoSQL databases need no schema to start working with data. In relational database, you have to define a schema first to connect the data, making things more difficult because you have to change the schema every time the requirements change. The next is auto-sharding. Sharding is the process of storing data records across multiple machines. NoSQL databases usually support auto-sharding, meaning that they natively and automatically support data across an arbitrary number of servers without requiring the application to even be aware of the composition of the server pool. The third is distributed query support. NoSQL queries are often faster than traditional SQL queries, so the cost of additional queries may be acceptable. Also, NoSQL database retain their full query power even when it's distributed in many servers. The next is an integrated caching. To reduce latency and increase sustained data throughput, advanced NoSQL database technologies transparently cache data in system memory. Many NoSQL technologies have excellent integrated caching capabilities, keeping frequently used data in system memory as much as possible. This removing the need for a separate caching layer. And the last one, sometimes the more important, is the economy. Relational databases require installations of expensive storage systems, proprietary servers, while NoSQL databases can be easily installed in cheap hardware clusters as transactions and data volumes increase.
Hi, my name is Andres Castro Cabrera and I'm going to talk about two of the four principal types of NoSQL databases. First of all, there are four different types of NoSQL databases: document-oriented databases. Two examples are MongoDB and CouchDB. Key value store databases with Amazon DynamoDB, Cassandra and Oracle Berkeley DB. Wide column databases like Google Bigtable and Apache HBase. And last, graph databases such as Neo4j and Titan. The first one is document-oriented databases. This type of databases store their data in documents, meaning that these kind of databases are great in performance and horizontal scalability. Horizontal scalability means that we can handle increased traffic used by adding more servers without changing the hardware of the existing ones and without increasing the complexity of the entire system. The documents are of common formats like PDF, JSON, XML, etc., etc. Documents in this type of database are addressed using a unique key. This key can be a string that refers to a URI or a path to the document. Document-oriented databases are used for applications where data does not need to be stored in a table with uniform sized fields, but as a document with special characteristics. Also, document-oriented databases should be avoided when the database needs relationships and normalizations. The main difference between relational databases and document-oriented databases is that in relational databases you must define a schema before adding any data to the database. This schema is the structure of the system described in a form that the database itself can understand. Here you define the size of the data, the relations between it, and the size of it. Meanwhile, a document-oriented database contains, as its name says, documents, which are the records that describe the data in the document. Documents are as complex and large as needed. Probably the most known document-oriented database is MongoDB. It was released in 2009. Developed in C++, it provides great features like fault tolerance, persistence, and consistency. In MongoDB, documents are stored mainly in Bison, binary JSON. Compared to JSON, Bison offers better storage and space efficiency, and a lot better scan speed. This means that MongoDB is well suited for content management, archiving in real time, etc. CouchDB was developed by Apache and released in 2005. It was also made in C++. In difference to MongoDB, it uses JSON documents to store data. It uses JavaScript as a query language and a built-in application called Fulton. CouchDB has great replication and synchronization capabilities, so it can be used in applications with data that changes occasionally. The next type of databases are key-value store databases. The key value store databases, it's pretty simple but powerful and efficient, and it works through an API. The data stored in these databases has two parts, a string that is the key and the actual data. This data can be anything, images, sounds, documents, etc., which is referred by a string key like a dictionary or a hash table. For this reason, this model is a lot faster than the relational model. High concurrency, fast lookups, and mass storage are the benefits provided by key value store databases. One of the problems of this simple schema is the difficult to make custom views of the data. Good examples where you can use this kind of database is if you want to store your user sessions, its online shopping cart, or its favorite items in the shop. All this meaning that key value databases are a great choice for online shopping and forums. Amazon DynamoDB is a key value database service that is fast, highly reliable, and is relatively cheap. This service is designed for great internet applications. It uses SSDs instead of traditional hard drives to store data. The data is replicated at least in 3 data centers to provide high availability and durability under failure scenarios. Oracle BigQuery is a high-performance database that provides key-value storage. It offers transactional data storage, highly concurrent access, scalability on large symmetric multiprocessing systems, data replication for availability and fault tolerance. The software is distributed as a library that can be used in the software that has interfaces that includes APIs for C, C++, Perl, TCL, and Java.
White columns stores. The way this hybrid works is by declaring so-called column families as part of a Rebus gem. White columns databases use a slightly different vocabulary, calling columns families, supercolumns, and calling tables. Supercolumn families, white column warehouse, can be the most fundamental databases on large business sites. Benefits for reasonably structured data, even if a data structure is somewhat variable between different database entries. White column database have the following advantages over the types of NoSQL. High scalable, well suites for distribution across multiple data, warehouse and computing nodes, sharing and modifying data directly from the database instead of dependence of application methods. Indexing. Some databases index different levels of columns to help with data processing. Granular, being able to update an individual columns instead of having to replace all data when something changes. Some examples using this are Google Big Data. It's a non-relational mechanism, a distributed and multidimensional data storage based on Google's proprietary storage technologies for most online and backend application of the company products. Bigtable is a continuous and ordered map. Each string in the map consists of a row column, various types, and timestamp values that is used for indexing. For example, a series of data from website that serves you, the important URL as the row name. The connect column stores the content of web page. Anchor contains any anchor, text or reference to the content page. At the province, the exact time of the data was stored and used to order multiple instances of a page. Apache Cassandra. Apache Cassandra is an open source distribution in new SQL, not only SQL databases. It's the perfect choice we need scalability and high data availability without compromise performance. It provides robust support from clusters than span multiples data centers. Cassandra was an architecture without a master in which the nodes of the data center are equally. The data is automatically distributed among all the nodes that are rigged or clusters. Graph stores. A graph-oriented databases represent the information as nodes of graphs and its relations with the edge of the graphs, entities, and edge relationships. The graph model is useful when the data to be stored as many interrelationships with each other and when the importance lies more on the interrelationship established between the data and of the data itself. Consequently, this type of databases tends to store little data about the real world, obvious to represent it with a lot of data about the relationship, unlike what usually happens in relation databases, where there is a lot of data of the objects. Of the object represent mainly in the properties and attributes of the relationships and few interrelationships, mainly in the properties attributes between the object represented by foreign keys. As an example, let's think about a twin in this context. A relevant twin is not measured based of the content, the text, but based of interrelationships that are established about how many times we forward retweeted, how many times I have been replied to word the followers from the author of the tweet, etc. At page. Search speed depends only on the number and specific relationships, not the dust, real-time results, intuitive and summary presentation of relationships, flexibility and constructs. Disadvantages is a difficulty to scale big designed for architecture with a single server, now considered the current language. The best no graph oriented databases, Neo4j. Neo4j is the most popular graph database is accompanied as open source models. Amazon Neptune. This graphic database can you visit through the Amazon Web Service public cloud and was open to public as an performance database. SAP HANA Graphs. SAP is created with SIP HANA platform based of a relation database management system that is complete with the intergraph graph orient HANA Graphs model. HornDB, this graphs database is considered one of the fastest models currently available.
Hello, my name is Oscar Eduardo Sanchez Gonzalez, and I will explain the advantages and disadvantages of NoSQL databases. As we have already said, this model have been more flexible and versatile than classic relations bases. Let's get to know some of these main advantages and weaknesses. Advantages. Adaptability to provide solutions is the strongest point of NoSQL. The possibilities of growth in the volume of data or the possibility to include change in the way we enter the data without the need to alter the structure allow to adapt quickly to a high dynamic environment like today's world. Elastic scalability. These databases are highly scalable and their decentralized character support distributed structures. That is, if the requirement to install more nodes to expand capacity, we can do so without problems. This will not disrupt usability for queries with the DB's low requirements. We don't need servers with a lot of resources to operate, The adaptability and flexibility of the DB's NoSQL allow us to start without low levels of equipment investment and expand capacity tailored to our needs. They are usually much more open and flexible databases. They allow to adapt to project needs much more easily than the models of entity relationships. They can run on machines with few resources. Optimization of databases require for a large amounts of data. Disadvantages: atomicity. Some of these databases do not incorporate the information atomicity features. This can result in the information not being consistent between nodes and might cause some problems in the analytic criteria. Poorly documented software. Being so relative new, NoSQL might be limited by the lack of information about the tools and their features. This can result in insignificant investment of time of money for those not in them globally in the area. Low standardization. There is no fully defined criterion between the engines used in this type of databases. The language trend to vary depend of the type the databases use. Utils. Most NoSQL databases do not contain a graphical interface for tool supports. Special no legend is requirement to be able to execute from some of them, which greatly limits those who are starting in this world. Although no SQL databases contemplate of atomicity of the statements and the integrity of the data. They endure that is called eventual consistency. Lack of standardization. There are many NoSQL databases and there is still no standard as there is an relationships databases and uncertain future is presumed in these databases. Cross-platform support. There are still many improvements to some systems to support non-Linux operation system. Let's look these points about the distribution of MongoDB. Main features. ad-hoc consultations. With MongoDB, we can make all kinds of queries. We can search the files, range queries, and regular expressions. In addition, this requirement can result in a specific field in the document, but it can also be a user-defined JavaScript function. Indexing. The concept of index in MongoDB is similar to that used in relation databases, with the difference that many document fields can be indexed and at multiple secondary indexes. Replication. Similarly, replication is a basic process in the databases management. MongoDB supports the primary secondary replication type. Thus, we can query the primary, the secondary acts as a ready-only data replicates and as a backup mode, with the particularity that the shield nodes have the ability to toss a new primary in the case the current primary becomes unresponsive. Load balancing is very interesting how MongoDB can scale the workload. MongoDB has the ability to run concurrently on multiple servers, offering load balancing of data replication service, so we can keep the system running in the event of the hardware failure. File storage. Leveraging MongoDB's ability for load balancing and data replication, Mongo can also be used as a file system. This functionality can graph is and included in the official distribution, allows you to manipulate files and content. Running server-side JavaScript. MongoDB has the ability to query using JavaScript, causing them to be sent directly to the database to be used. Disadvantages: not a suitable solution for applications with complex transactions. You don't have a replacement for environment solutions. It's still a young technology.
Now we're going to talk about the NoSQL security. First of all, most of NoSQL databases do not provide any feature of embedding security in the database itself. Developers need to impose security in the middleware, and also the security issues that affected by this type of data gestures were also integrated in the NoSQL databases, as well as new ones imposed by their new features. Security may be difficult owing to the structured nature of the data stored in these databases. This also we have to take care about the distributed environments and also the cost of security in contrast to performance. And there is also no strong consistency in this type of databases. There are five main major security challenges in this type of databases. First, the threats posed by distributed environments. In this, the distributed environments increase the attack surface across several distributed nodes. This gets us to compromised clients in which malicious data gets propagated from a single compromised location. Now, the authorization and access control. In this, there are two important challenges: the possibility of how to define security policies for schemaless or dynamic schema databases, and also in performance, we have to take care about the availability versus access control overhead, how to manage cost of access control. Now, on this point, we will give two examples of databases how they manage this type of authorization and access to control. First, Cassandra. By default, there is no authorization, and privileged admins can't grant the privilege on resources to a selected user. Now, MongoDB, by default, there is no authorization. The provisions of authorization on a per database level by using a role-based approach. This means that the authorization only restricts the level in the tree of the structure of the data. Now, the safeguarding integrity. This means that enforcing integrity constraints is much harder in NoSQL database system. This means consistency is in contrast with availability and performance. Also, the transactional integrity is in contrast with its soft nature. Now, the protection of data at rest. The encryption is widely regarded as the de facto standard for safeguarding data in the storage. Most industry solutions offering encryption services lack of horizontal scanning and transparency required in the NoSQL environment. Only a few categories of NoSQL databases provide mechanisms to protect data at rest by employing encryption techniques. Now we're going to explain two examples of databases that how they are affected by this point. First, the Cassandra. It uses a transparent data encryption, abbreviated as TDA, to protect data that is written to disk. The commit log is not encrypted at all. By the other side, MongoDB, in his data file, they are never encrypted. And the last point, user data privacy. The privacy is the main challenge of the Web 2.0 and virtual social networks. And there is a problem. There are large amounts of user-related sensitive information in NoSQL databases. So which kinds of methods is applicable in practice for NoSQL databases? This means the access control, encryption, anonymization, etc. Now, the NoSQL minor security challenges. First, the authentication. And Cassandra, by its way, by default, there is no authentication, but it has a password authenticator. It can also further provide Kerberos authentication. By the other side, MongoDB, by default, there is no authentication, but there is support for authentication on a per database level. That's the point that I explained before. Now the audit and logging. NoSQL databases has a poor logging and a log analysis method. Cassandra, by its way, auditing is available in Enterprise Cassandra. MongoDB is far behind in implementing the desired security logging and monitoring. Now the protection of data at motion, communication between the clients and nodes, and the communication between nodes, RCP over TCP IP. And last, API security. APIs can be subjected to several attacks such as code injection, buffer overflows, common injection, as they access to the NoSQL databases. This is why the programmer have to take care about this kind of insecurities. Cassandra, for example, is vulnerable to injection. MongoDB, the operation where can be used for injection too. And in summary, the NoSQL security challenges are threats posed by their distribution nature, the fine-grained authorization and inference control, the integrity constraint and definition and control, the lightweight transparency encryption of data in rest, users' privacy, etc.